today we're going to flip a switch. So for the past week, we spent using the distributive method and multiplying it through. And now we're going to work in the opposite direction. So what you were giving me before as the answers are what I'm going to give you to start with. And we're going to factor them. Remember, if I gave you the number 8 and I would say, what are the factors of 8? You would say like 2 and 4. Two things that multiply together to give me 8. So we are going to take out, dividing out coefficients and variables that every term has in common. Okay? Factor each polynomial. So, two terms here. 27y squared plus 18y. We have to find the biggest number that divides out of 27 and 18 evenly. 9. I want to take as many y's as I can, but I have to be able to take them from both. How many y's can I take from them? Just one. So we are going to divide out a 9y. Now, that 9y doesn't just disappear. We got to keep track of it. So 9y is going to go out front. Now put a parenthesis and divide. 27y squared divided by 9y. 3y. 18y divided by 9y. 2y. Just 2 because your y's cancel. Before you quit, you look back at your parentheses. Did I miss a number that I could divide out of 3 and 2? Did I miss a y that I could take from both? No. This is your answer. If you think about it, I would have given you this last week, right? And said multiply. And you would have distributed. So we are going the opposite direction. Can you absolutely check yourself? 100%. Redistribute and see if you got the original problem. If it's 3 terms, process doesn't change. I need the largest number that can divide out of all of them evenly. 2. How many A's can you take from everyone? Just 1 A. How many B's? Just 1 B. Now don't lose that. That goes out front. 2AB, which you're dividing out, goes out front. What do I end up with? Nice. Plus 1. Very good. 2 divided by 2 is 1. If you start with 3 terms, you're going to end with 3 terms. Again, check. Did you miss anything that you could have divided out here? Any letters? Okay. How about you guys go right below that. Do this one on your own. Find the largest number you can divide out of all of them. And then find out how many of each letter you can take. Mm-hmm. Correct. Mm-hmm. 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 What's the biggest number you can divide out? A 1. Because this is really just a 1 here. We can't divide anything else out. How many U's? Just 1? How many T's? Don't lose that. 1 UT goes out front. And you're left with? Nice. Nice. Do the one right below that. Go one more. Straight down that side. 6xy. Yes. You end up with 2. Nice. Excellent job. Excellent job, you guys. Okay. So factor is what can I divide out that every single term has in common? Okay. Flip the page. Now notice what we just dealt with, there were either 2 terms or 3 terms. If you have a polynomial with 4 terms and it says to factor, we are going to look to group factor. We're going to separate the terms and try to find something that each group has in common. If I look at this right now, there is no number that divides out of 4, 8, 3, and 6. Agreed? And there is no letter that I can take out of all of them. Agreed? So as a whole, I can't divide anything out how I was previously doing. But what if I group these first 2 together and I group the second 2 together? These are just like my imaginary blocks. In this first parenthesis, just these 2 terms, what can I divide out?
4.
That's it?
4R.
4R, yes? What do I need to do with 4R now? Put it out front. And what would be remaining? 1Q plus 2. Go to the second parenthesis. What can you divide out of 3Q and 6?
3.
Okay. Anything else besides 3? Okay, so what happens to 3? Put it out front. Is it a positive 3 or a negative 3? So put that plus 3 so we remember that. What do I have left? 1Q plus 2. That's interesting. What do you notice? They match. If that doesn't happen, you screwed up. Group factoring, this will happen every single time. Now, I want everybody to understand. Technically, I lost my other pen. Technically, this is one term, right? They're multiplied together. And technically, this is another term. Follow me? So I now can divide out of this term a q plus 2 and this term a q plus 2. That's my parentheses that match. That goes out front. Q plus 2 cancels. Q plus 2 cancels. What's remaining?
4R.
And a plus 3. Those 4 terms were created by 2 binomials multiplied together. If you factor out and your parentheses don't match up, you screwed up. Something is not right. Okay? Let's go down.
Wait, is that Q plus 2 have to be in parentheses?
Yes, because if it's not, that's a great question. Because if it's not, then it looks like just the 2 is being distributed, and you want the whole thing. Yes. Go down here. Group the first 2. Group the second 2. What do the first 2 have in common? 3p. So I factor that out front. What am I left with? 1n plus 5. What do the next 2 have in common? Nice. It's a negative 4. Notice how they're both negative. I absolutely would agree. Not just a 4. It's a negative 4 that they both have in common. So here's, remember on the last one I said is the 3 positive or negative? In this case, the 4 is negative, right? So it's really minus 4. And then what's remaining?
1N.
Did you accomplish what you wanted?
Yeah.
Do your parentheses match? Okay, so now we are going to factor that parenthesis out front, n plus 5. So I put n plus 5 out front, cancels here, cancels here. What's remaining? 3p minus 4.
Will we type it to Alex? Is that what we want to send it up to?
Yes, exactly. Yep, 2 sets of parentheses. Yep. I want you to go to the right. 2xy plus 7x minus 2y minus 7. Do this all on your own once. What should I divide out of the first set? A 1 and an x. Did you go 1x like that? Okay, so 1x goes out front. What are you left with? 2y plus 7. I don't know about some of you guys, but now that I know that parenthesis, my brain automatically starts working like, whatever I pick, I got to get 2y plus 7 in my other parenthesis, right? That's my whole goal. So what can I factor out of negative 2y and negative 7? A negative 1. So the negative 1 goes out front, and I'm left with mission accomplished. Yep, they match. So that parenthesis that matches goes out front. 2y plus 7. Make sure it's both in parentheses. What am I left with? 1x minus 1. Did you? What'd you do?
I grouped the 2xy and negative 2y together, and then the 7x negative 7 together. And I grouped those. Yeah.
Totally fine. You got the same thing, right? Were your parentheses flipped?
Yeah.
Yeah. But everything inside your parentheses matched? Totally fine. 100%. In 8 years of teaching, I've never had a kid do that. So props to you guys.
I thought that was how you had to do it, because the negatives and positive. I mean, like the numbers had to match up.
Technically, you don't have to, but it's not wrong what you did. Rearranging it. Bottom left. 2mk minus 12m plus 42 minus 7k. Take a hint from what they just did. You maybe want to rearrange things in this problem. As long as you keep track of the signs. I didn't rearrange, okay? I divided a 2m out of the first, I get 1k minus 6. But when I go to look at my second parenthesis, Ms. Hoff told us I got to match this perfectly. And the k is out front. In this parenthesis is the k out front. What could I do to get it out front? I mean, technically I can change the order of this, yes? As long as I keep the positive with the 42 and the negative with the 7. Follow me? I mean, technically I could write negative 7k plus 42, yes? Now, I know I got to get k minus 6. What am I going to have to factor out on this? A negative 7. So I get k minus 6. Then I would factor my k minus 6 out front, and then 2m minus 7. Not the only way to do this, though. Anybody group it differently? Did you put your k's together? Anybody? So if you put 2mk minus 7k together, and then negative 12m plus 42, you could factor out a k, 2m minus 7, and factor out a negative 6, 2m minus 7. 2m minus 7 goes out front, k minus 6, same exact parentheses. So you can regroup if you need to. Jackson.
I got negative k plus 6 and then in parentheses 2m plus 7.
Ooh. If your signs are different, all your signs should be different. Negative k plus 6 I'm okay with.
And then 2m plus 7.
It should not be plus 7.
Oh, plus.
If you get a 2mk, negative 7k, you've lost your negative right there. Yep. When you're rearranging, make sure you take the sign with them. Questions on factoring. You're looking for the GCF. If there's 4 terms, group factor. Front page 2 terms or 3 terms, you're looking the largest number and the most exponents, variables you can take out. Okay. Next page. We're going to have the word solve in here today. Okay, when we would solve equations, we would actually get x to equal 12, y to equal negative 2/3. So solving polynomials can be simple. So solving equations with multiple factors. So what we need to do is first we have to factor. First we have to break this down. Then we'll set them equal to 0 and solve each separate one. All of our problems today are going to have multiple answers. Okay. First one, x plus 5 times x plus 5 equals 0. This is already factored. How do I know it's already factored? It's multiplication, right? Your first factor is x, and then your second factor is x plus 5. There's parentheses indicating multiplication. Factor 1, factor 2. So as long as it's equal to 0, which it is, we split it at the factors. And we set each one equal to 0. So we would say x equals 0, x plus 5 equals 0. How do I solve x equals 0? It's solved, x is by itself, right? How do I solve x plus 5? Minus 5 minus 5, x equals negative 5. Your answers go in braces, the little squiggly lines. You list the numbers. It doesn't matter what order they're in. Just make sure they are separated by commas. 0, comma, negative 5. That's not an ordered pair. You're telling me that x could equal 0 or x could equal negative 5. Go to the right. How do I know it's factored? They're multiplying. What things are being multiplied? 5x and x plus 3. So split them where they're multiplied and set each one of them equal to 0. 5x equals 0. X plus 3 equals 0. 5x equals 0. How do I solve that? Divide by 5. You can't divide 0 by 5. What is it? Oh, 0 on top's okay. 0 on bottom's the issue, right? How do I solve x plus 3 equals 0? Subtract 3. X equals negative 3. In my braces, I list my answers. My two answers are 0 and negative 3. Go down. How do I know it's already factored? There's multiplication happening right here, right? So one of the factors is 2y plus 3. One of the factors is 2y minus 7. It's set equal to 0. So I split them where they are multiplied. So I say, 2y plus 3 equals 0, and 2y minus 7 equals 0. How do I solve for y on the left? Subtract 3. 2y equals negative 3. Then divide by 2. Y equals negative 3 over 2. On the right, what should I do? Add 7. 2y equals 7. Divide by 2. Y equals 7 over 2. So in my crazy little braces, negative 3 halves and 7 halves. So all three of those were already factored for us, and we saw that because the number was right next to the parenthesis, or we have two set of parentheses right next to each other, which all indicate multiplication. Bottom left. Not factors, agreed? Yeah, I'm multiplying 4 and x squared, and I'm multiplying 24 and x, but there's not two separate pieces being multiplied. So guess what the first thing I have to do here is? I have to factor. So it's set equal to 0. Now I have to think back what we did right at the beginning of the hour. What can I factor out of 4x squared and 24x? 4 and an x? Now, don't lose that. What do you do with it? Goes out front. When I factor out a 4x, what am I left with? 1x plus 6 equals 0. Now I have my multiplied terms, yes? Split where you're multiplied, and you say 4x equals 0, x plus 6 equals 0. How do I solve on the left? Divide by 4. 0 divided by 4, 0. X plus 6 equals 0. I subtract 6. X equals negative 6. Nope, order does not matter. Good question. As long as you have the comma in there, you're totally fine. Okay. That last page was if we were not having an Alex assignment. Okay. Alex, grab your scratch paper.
Can we do that instead?
No, you'll want Alex.
It's so easy.
Grab your scratch paper. Get started.